Hey, what's up guys? In this video, you can learn about covariance and contravariance and their significance in programming languages. Covariance and contravariance are one of those topics which probably most of us programmers have heard or learned at some point, but as it turns out, it is one of the most confusing concepts out there. Also, it is occasionally asked in programming and tech interviews, so it would not be a bad idea to better your understanding about these two while you still can. So before we try to understand the concept of variance, we need to talk in brief about types, subtypes, and their substitutability in programming. For example, if fruit is a type and mango is a subtype, then the places where fruit is used in an expression, we should be able to substitute it with the mango. This relation can be maintained for entities implementing the types and subtypes like functions and lists. Now, it is not hard to understand that there is a relation between the parent type and the children type. In other words, there is a subtype relation between fruit and mango in a specific direction. One way to define this relation is by having an ordering of types, like it can start from least specific and will go towards more specific. In our example, it will start from fruit and it will go towards the mango because fruit is least specific and mango is more specific. This is true for all subtypes, and this subtyping relation is where the concept of variance comes in. There are entities and components in programming languages like enumerables, functions, arrays, lists, etc. that implement the simple types and subtypes like fruits and mangoes. Remember, I earlier said that we should be able to replace a type with its subtype. This can also be done with components implementing the types. For example, in an expression, a component implementing a fruit type should be replaceable with the same component implementing the mango type. The ordering or direction in which this substitutability can work will dictate if it will be called a covariance, a contravariance, a bivariance, or an invariance. Let us now see some code examples of all of these concepts one by one and try to understand how these work within the code. If in an expression we are able to replace a component implementing a parent type with the same component implementing its subtype, then the type ordering will be preserved and it will be called as covariance. So over here we can replace a fruit with a mango, but we cannot replace a mango with a fruit. Similarly, if we have two enumerables, one of them is of type mango and another one is of type fruit. Over here, the fruits can be replaced with mangoes, but mangoes cannot be replaced with fruits. What this means is, for I enumerable types, a more derived type component can be assigned to a less derived type component. So over here, the ordering of subtypes is preserved. This is why both of these examples come under covariance. On the other hand, if in an expression there is a component which implements a subtype and we can replace it with the same component which implements a parent type, then the ordering of types will be reversed and this will be called as contravariance. The simplest example for this is when we are using functions. So let's create two functions. The first one has a type of fruit as an argument and the second one has a type of mango as an argument. Now I will show you how the ordering is reversed over here. So this is going to be contravariance. Let's first create an action type which is going to accept the argument of type fruit. Let's just call it fruitinfo, and we can safely assign this getFruitinfo function or method within this type. Similarly, we can create another action type which is going to be for the mango type argument, and we can just call it mangoInfo, and let's assign getMangoInfo over here. If I will try to assign mangoInfo within fruitinfo, then you will see that the compiler will throw an error because over here the ordering is reversed. We cannot assign a more derived type component which is mangoInfo to a less derived type component which is fruitinfo, but we can safely assign fruitinfo to mangoInfo, and this shows that ordering is reversed over here. So this comes under contravariance. If both covariance and contravariance can be maintained when substituting, then it will be a bivariance. I was unable to find any code example for bivariance, but if you think that there is one, then feel free to let us know about it. Finally, if no substitutability can occur, then the component implementing the types will be invariant. For example, the list types in C# language are invariant. So if I try to do something like this, let's try to assign a fruit list to a mango list, or maybe try to assign a mango list to a fruit list. None of them are going to work because the list type constructor is invariant. It will not allow us to substitute the types or subtypes in either order. So neither the forward ordering of subtypes nor the backward ordering is going to be preserved over here. So this is why this is a perfect and simple example of invariance in .NET. These were, I believe, the simplest definitions and code examples of covariance and contravariance that you may find anywhere without unnecessarily complicating things. Still, if you feel that you have any question or confusion, then you can either use the comments area or you can join our Discord server. The link is there in the video description. Finally, if you like this video, then please place a like on it and subscribe to this channel for more such videos. I am Nitij and I will see you next time. Till then, stay safe and have fun.